So welcome to the malware analysis class. I don't know if anybody saw a class show up in Blackboard at all. If you have, I don't expect that you have, so if you have, raise your hand, because that will surprise me. I'm getting that set up since, as many of you are aware from the cloud class last semester, but some of you are new, I'm not actually a full professor or anything, so getting Blackboard and all that administrative access takes a little bit longer for me. Any of you who are enrolled in the cloud class that comes up after this will probably run into the same problem, or will probably encounter a similar problem. So that said, we'll get Blackboard access set up. In the meantime, I will set up a public website that I'll share a URL with all of you for in the next lecture. That'll be where a lot of the course materials will be hosted. That's actually going to be hosted on one of Dr. Franco's servers. So some of you who are familiar with Dr. Franco's class might already know the URL. So, but I don't have that hosted yet, so I'll get that set up. Again, this is malware analysis, so if this is not the class that you're expecting, then here's the warning. So a little bit about me, kind of non-traditional as far as some of the other professors that you're going to encounter here. I'm currently a PhD candidate in computer science engineering. My focus is in cyber operations. So back in 2014, the U.S. National Security Agency actually granted the University of Cincinnati a certification of academic excellence in cyber operations. So they have a Center of Academic Excellence here that's focusing on that field of study. That's kind of where my research focus is right now. As you can see down at the bottom, malware analysis is actually one of my primary research focuses, and I'd be happy to talk with anyone about that stuff, after class or offline sometime. In addition to teaching this class and going to school here, I'm also a cyber intelligence analyst, which includes malware analysis at GE Aviation. My career there actually began writing software for them to do attack detection and things like that. When we were able to detect and prevent a large number of attacks, we decided that we would analyze a lot of the things we were detecting. So they hired me on for malware analysis. So the course that I'm teaching now is going to be based upon a lot of the expertise that I've gotten in that field, and also working with other people in that area, including people who do this work for, for the government mission via the Center of Excellence. So I've got office hours. I don't have an office since I'm not a professor again. However, Monday, Wednesday, Friday, I have to be here until 3:30 for another class. Doesn't really make sense for me to drive all the way up to Blue Ash after that, so I just kind of hang out until it's time to go home. So if you want to catch me anytime after 5:30 or 3:30 on a Monday, Wednesday, Friday is definitely a good time for me to set up an appointment. Usually I'll meet someone at Starbucks or the library or something like that. Don't feel bad if I can't meet with you immediately. I definitely will try and go out of my way to set something up that works for both of us. Additionally, kind of my background has always been in the Linux community and also a FreeBSD developer. So those of you who follow any of those projects, I actually have some contributions in those areas, and a lot of kind of my approach to attacking the malware analysis problem and all that stuff is going to be very kind of Linux and Unix focused just because of that. So I would recommend, if you do want to follow in class, I'm not going to be providing a whole lot of like Windows alternative to the way I'm doing something. Definitely getting experience in Linux, like Ubuntu or something like that, if you don't already have it, is definitely probably going to be a must for doing some of the work in the class. And we'll get into that a little bit later when we start talking about kind of the lab environments and everything. So also tend to sometimes pepper my slides with random images from the internet. So here's one of Nyan Cat that I found that was very nice. So how I thought I'd start this off is talk a bit about what malware is, and also maybe set some boundaries around what malware isn't. What I usually like to consider it to be is malware is any unwanted software or code that's on a system or used on a system that's intended to perform some unauthorized actions on or with that system. So generally what I look at it is it's primarily a program. A lot of people think of that as an unwanted program running on their system. There's even a really common abbreviation called PUP, which is potentially unwanted program, that some antivirus engines will flag. I kind of look at it as it's either executable programs or even files that cause controlled code execution to occur. So malware can be a exe file, if you're familiar with the Windows jargon, or it can even be like a Microsoft Word document or something like that. So we're actually going to look into analyzing both of these types of artifacts, as well as a bunch of others in this class. So we're not going to stick specifically to executable code. We'll also go into how document files, PDF files, things like that are used to cause those applications that are supposed to read them to behave improperly, and then also provide access, also known as like exploits and things like that. So common objectives, I listed them up there. I'll run through these. So download a program to run on the system. You may see a lot of times that is a common approach, which is I'm going to send somebody a document. The document has like a macro in it or something like that. Macro downloads a program off of the internet somewhere that I've hosted previously, and then it wants to run that on the system. Delete files too, like if I just want to cause some havoc in someone's life, I might write malware that's designed to delete files. This is designed to, say, make their system unusable for some reason. Maybe I just don't like them. Encrypt and delete files. I included this one specifically because ransomware is a really common term that's used in a lot of the cybersecurity discussion these days. That's basically where you try and encrypt, delete files, and then you provide, say, a contact information for somebody to get a key to decrypt their files in exchange for some amount of money. So ransomware, ways to generate money, are one of the really common motivations behind a lot of, say, malware distribution. Remote access, I'd like to get access to your system over there and actually use it for any sort of bad purpose, like I want to go and look through all your documents or all your pictures and take what I want, things like that. I want to pretend to be you so that I can go and click on a whole bunch of things, like I can go visit a whole bunch of websites I'm not supposed to visit, that type of stuff. Impersonation, for instance, or I want to send a bunch of emails as if I were you. All of those types of things are possible via remote access. Some of you might be familiar with pranking other people on the systems. In office environments, this tends to be a really common use of malware. And in most office environments, it's generally frowned upon, and even sometimes grounds for some sort of punitive action. Private information theft, so I kind of mentioned it earlier, but also there's some malware that, rather than just providing general remote access that lets you browse all your files, there's some malware out there that's designed to run on a system and look for specific files that it's told about ahead of time. Say, pull all of your contacts out of your contacts list, or go into your web browser and steal all the passwords that you've saved in your web browser, that type of stuff. So that's an example of private information theft. Wait for you to log into your bank account. Once you've logged into your bank account, then use that session to go and steal all the private information that you usually secure behind the password in your bank account. All sorts of things like that are other examples of private information theft. Anonymized attack source. A good example of that is things called like botnets and things. So I'd like to get a program running on like this system and his system and his system and her system, so that I can send them all a command to go and attack someone that I don't like. It looks like the 3 of them attack that person, even though I'm the one that launched the attack. It allows me to attack somebody or hurt someone that I don't like without people being able to tie it back to me very easily. So there's also many, many more. I'll say that just working in the field of information security, ransomware is a really great example of one that, there was a new type of attack that emerged and has now become extremely popular. Just like, in regular legitimate industry, we have a whole bunch of innovation that produces new products of value and things like that. Same thing is true in malware. Every single day, there's people trying to think of ways that malware could be used to achieve some sort of goal that's high in demand. And there's people who are out there who are constantly writing malware every single day. Because of that, because it's an ongoing, constantly innovating industry, it's where malware analysis comes in and is really handy. And so, say in your lives after this, as you're working, in whatever security capacity or research capacity you're in, the stuff in this class will hopefully be helpful to that end. So another thing that I'll just throw in here is a disclaimer, just because I know we're all adults here, but I have to put this up here anyways. We're going to be messing with real malware. We're going to be messing with things that allow you to build real malware. So the potential does exist for you to write something that can attack, someone that's out there publicly. Don't use it for that. All of this is around for, say, academic research purposes only. We're really, I'll give you specific targets that are part of a contained lab environment that we'll use. You'll actually install, say, VirtualBox and some VMs on your system to go and play with that stuff. You're not to use any of this stuff for bad, use only these powers for good. So that's kind of the disclaimer here. There's a huge amount of others that you'll encounter on some of the websites that I'll give you links to later on in class as well when we're going over specific topics and looking at specific tools. In addition, because malware analysis involves a decent amount of software reverse engineering and software cracking and stuff, these people who put together malware samples typically will put them together using a lot of the same mechanisms that legitimate software authors use to try and prevent you from being able to, say, crack copy protection and stuff like that. So a lot of the tools that you'll see for this also are used for those types of things. Don't use them for those types of things. You'll probably find that information on the internet as well. So just wanted a quick disclaimer. Also, I tend to shy away from mandatory texts. I know that those of you who are in my cloud computing class last semester, I had one text that everyone was required to get, and then I gave tests that were based out of that. I won't be giving tests that are based out of either of these books, but if you do want books that are really good to accompany this class, these two are really good, and these are two that I've actually purchased and that I do intend to, say, pull some examples out of for class and things. So I will try and, these are good ones if you want some background and are running into, say, dead ends trying to search the internet and do your own research. These are a good starting point. I surveyed a large number of people. Yeah, just go ahead and sit down. I surveyed a large number of people who I work with, and there are about 5 different books that came up, but these 2 were the ones that were kind of had unanimous recommendation around them. I know one of the big things too is that both of these books are relatively new compared to some of the other texts that are out there as well. Since this is a relatively new field, like cybersecurity and everything, really, it's really been since about 2008 that it's been on a lot of people's radars. Most of the texts that are going to be between, say, less than 10 years old or something like that. So texts that are only, say, 4 or 5 years old are generally considered to be really new compared to ones that are 8 years old. So there you go. Also, just, quick pitch. NoStarch.com has a large number of other really good books. Some of you are probably familiar with Safari books and O'Reilly books and stuff like that. I'd say this is like another really good source for books. So about this class, we're going to divide the class more or less halfway, so right around spring break time actually is where the division is going to be, between what I call the static analysis or the how does it look. So if I have a file or a document or anything like that, and I'm looking at it on disk, so I'm not opening it with I'm not opening a Word document with Word, or I'm not running an exe on a system or anything like that. I'm dealing with it, you could say, at rest. What does it look like? How would I find it if it's just stored on a disk drive or something like that? If I was analyzing the disk drive, what characteristics do I try and use within the file that are visible that can help me analyze it and also help me identify it from other files in the future? And then the second phase is what I call dynamic analysis, or runtime analysis, which is how can I identify the malware, how can I analyze the malware through the system effects that are produced by loading or running the artifact in a contained environment or in a lab. So in our case, it'll be in a virtual machine. How does it behave? So how does it change the system that it's run on so that you have some evidence that that piece of malware is installed or running on a system? So, and then kind of how the homeworks and all that stuff's going to work. A large amount of this class is going to be kind of practical methods and stuff like that. So we'll do a lot more kind of applied work, I guess the best way to put it. We're going to be doing a lot of lab assignments. There's not going to be a whole bunch of, say, pages of lecture notes, chapters to read, and things like that, topics to memorize or definitions to memorize or any of that stuff. There will be a handful of vocabulary that we do try and stick with, and I'll have definitions for that. But that's more just so that we all know that we're on the same page and we're talking about this stuff. One thing I will say that even being in the field for the amount of time that I have, it's still very easy to talk past one another because we all like to call different things different things. So like the great example is virus versus Trojan or something. There's two words that mean completely different things to different people depending on who they are. Definitions become important, but to just try and give clarity on what we're talking about, that's really the extent at which we'll do definitions and stuff. Most of it's going to be homework assignments. There'll be labs, so you'll be responsible for analyzing something using some of the tools and techniques that we've covered, say, the week before, in order to attack a lab during the same week that you're learning, say, topics that are supposed to set you up for the next lab. I may have some that build on top of one another, which is probably a good reason to not, say, fall behind. But a lot of them, just because of the nature of this, we're going to be bouncing around different types of malware. A lot of them are going to be pretty independent of one another. And then we'll end up probably having a final project, not a final exam. And a final project will be basically a bigger homework assignment of some sort. I don't have all of these things put together yet. So I didn't come into a bunch of material ahead of this class like I did with the last one. So I'm kind of putting together a curriculum as I go. Also, let me see, I think I've got, well, I'll get into that in a second, the course schedule and everything. But up here, I have a list of technologies that you should familiarize yourself with. So I already talked my own personal experience with Linux. If you ask me questions about, hey, professor, I don't know how to do the following thing in Windows or whatever, I may not know either. It's probably better to get that answer from a lot of you. If you say take some time to learn to use Ubuntu and you want to know, for instance, how to how to dump how to do a binary dump in hexadecimal of a exe file or something like that, I can give you some pointers on how to do that in Linux. I don't even know, other than to search Google, which is what I'll probably tell you to do, where to go to find a hex viewer tool for Windows. So I have not used one since Windows 3.1. I do not personally have a preference as to which virtual machine software you use, but you will want to learn one of them. I chose to learn VirtualBox a long time ago. I haven't ever chosen to learn VMware. So any questions about I can't get this to work in VMware and all that stuff, again, will be ones I can't answer. However, I'll probably point you to how I would do it in VirtualBox, and maybe that'll be helpful. I don't know how similar the two are. I personally just picked on VirtualBox early on because it's an open source virtual machine that's somewhat based on QEMU, which is also an open source project. The open source nature of it was very attractive to me because you can see the source code for what's going on under the hood, and you can mess with it. So, for instance, if I ran into problems with VirtualBox where it seemed to be buggy in certain areas, I could actually send some suggestions to the authors as to say where the code might be faulty, that type of thing. So you'll see there's also that theme here is kind of favoring some of the open source tools. There's also a project called IDA, which is the, I forget what it stands for, but disassembler is the DA. There is a very expensive for-pay version of it. You're welcome to get that if you want. I don't even buy that for myself. There's also a free version. So if you go there, I think it allows you to download for free IDA version 5.0 or something. That's actually very well featured, and I won't be using the professional version for this class at all, so that I can guarantee that, which they do purchase that for us at work, but I'll use a free version so that I can guarantee that anything done in class can be done with the free version. Immunity Debugger, there's a whole bunch of graphical debuggers for Windows, and that's just a skill or technique that I would recommend strongly that you practice if you don't have a lot of experience with that in the jobs that you've done up to now. Immunity Debugger is one that's extremely popular in the malware analysis reversing community, but honestly, I've used GDB in Windows before to go and analyze malware too. If you're more familiar with GDB's interface, then feel free to use GDB. If you're more familiar with some other debuggers, those are good too. I will say that debugger that comes with Visual Studio and some of the default debuggers in Windows might be a little bit difficult to use because they are typically the debuggers that a lot of code obfuscation techniques are designed to confuse. So the standard debuggers that come with Windows, the standard Microsoft developer tools, most malware authors don't want you to be able to analyze their malware with those tools. So when they do put in a whole bunch of obfuscation, as they call it, it'll be to try and confuse those tools. So if something doesn't work in those tools, which I know are downloadable via DreamSpark, that could very well be why. And I'd recommend looking into something like this one that's more tailored towards malware analysis. Also, I'd strongly recommend learning some sort of what I call a scripting programming language or interpreted programming language, just because for some of the work, you'll probably have to come up with creative, tiny programs to go and manipulate bytes or extract bytes from a piece of software after extracting bytes from another piece or another space within that file. I found that something like Python or Perl generally lend themselves very good to this. Trying to write Java to accomplish the same thing will require 20 lines of setup code or whatever, which you're more than welcome to do. but then also requires you to run it in a JVM and everything like that. You know, I would recommend that if you don't know any of those, like Python would be the biggest one, to just learn them, just because I've seen that is extremely popular in the, out in the private sector anyways. And then finally, one that I put up here is Yarra, which was a project by a grad student out in, I believe, Spain. His name was Victor. So he's since moved to Google, and Google actually purchased VirusTotal, which is a kind of lightweight malware analysis site on the internet. You can upload artifacts to, and then it can give you an idea of whether it looks like malware or not. So he actually works for them now in that division, and because he works for them, they actually pulled this project that he made, Yarra, into their kind of company brand or whatever. So it's one of their company portfolios within their, or tools within their portfolio. Strongly recommend you go to that. There's really good documentation as well as a lot of examples. And also there's a lot of libraries on the internet for it. We will definitely spend time, like at least 1 or 2 lectures on that particular tool. For lack of a better term, it's like grep, if you're familiar with that tool, or like an advanced find tool that allows you to look for patterns, look for byte patterns within files. And it has a very expressive language for doing, say, pattern searches and pattern matching and even byte extraction. So I'll make sure that this stuff also gets replicated when I get a site up. And as we use more tools in class, or even if some of you find tools that I haven't talked about and they happen to be really useful to you, I by no means believe that I know all there is to know about this. So if you find something that's really useful and helpful, definitely send it my way and I'll try and get it up there. So there's so much to learn in this field that I can't possibly know it all. So there you go. So the tentative schedule, I say tentative because as I said, I haven't taught this class before. I might find that some of these topics really are easy to cover within 1 day rather than 2 days in a lecture. In other cases, I might find that some of you want to spend like an extra lecture on it or something like that. So when we get to these, I'll just kind of play it by ear. I did kind of leave, so these last 2 weeks here, start to talk more in terms of using what you've learned about malware samples to create mitigations and create prevention within a system. That also means that there's about 4 days or so of kind of flex time where we can, if we need to insert an extra day of schedule into talking about, say, the OLE document structure or something like that, we can, and then we just make it up down here somewhere. So, and then finally, spring break is going to be the 10th week. Next week, Monday is a holiday, but there will be class here on Tuesday. So Tuesday classes aren't canceled just because of the Monday holiday. And then finally, finals week is going to be week 16, which I remember correctly is the last week in April. It's like the one that's the 27th or something. So the way I typically set that up is the Friday evening of that week will be when the projects are all supposed to be turned into Blackboard. So kind of diving into the prerequisites a little bit. There were no specific technical prereqs for signing up for this course. However, depending on your experience, your background, some of the concepts in the course might be easier, might be easier, more natural, or you might already have a lot of the background for them, and others you might find that you're going to have to do your own research in the class that some of your peers don't have to do. So a really good example of this might be if we're looking at Windows malware or we're looking at Linux malware. you might not have very much experience in the internals of either one of those operating systems. Or you might not have taken the operating systems course yet. I'm not going to rehash the entire operating systems course. I will give a brief explanation about these. For instance, in Windows, we might talk about the registry, which is like the global configuration space in Windows. When I start going into registry keys and everything like that, I'm not necessarily going to make assumptions that you know what each one of them means. I'll give a little background on the purpose of whichever ones I'm talking about and why they're important. But there is a Windows API around reading them, writing them, acting upon them, things like that. If you don't understand all that stuff, you might want to fill in the gaps there. Ditto for like the Linux POSIX API, things like that. I don't have a cheat sheet for the Linux POSIX API, but if we're looking at a C source code, or we're looking at disassembly that's making Linux system calls into the POSIX API, I will assume that if you don't know a particular POSIX function, you can log into like UC file space and use the man program to read the man page for that thing, or go on the internet and look at any one of the Linux man pages for that API call. So, so if you aren't familiar with that, then you may want to go online and find a really good reference site that has good man page documentation for Linux. Likewise, there will definitely be some C or C++ and Python. You'll be expected probably to read code that wasn't written by me or written by any one of you, and was probably written by somebody who wasn't the best programmer. And also there will probably be some writing of any of those too. And then finally, assembly language, same rules apply. We'll probably stick with the 32-bit stuff, but I might add some of the 64-bit stuff. Don't get too hung up on it, and I'll explain. I definitely will explain the key distinctions between the two of them. But for the most part, reading your 64-bit assembly is almost identical to the 32-bit assembly. The only difference is that there's more memory and there's more registers. So I put down here, UC offers an operating systems course, and I don't believe they call it assembly language anymore. I can't remember what they call it now. But there is an assembly language course as well. Both of those both of those classes are kind of the, if you know those, then you have a great background or foundation for the class. However, if you haven't taken both or either of those, you can still, be proficient in the class. You don't need to be an expert in all of that. Like operating system scheduling algorithms aren't going to help you out a whole lot for the malware analysis class. You'll just have to make sure that you do fill in the gaps that you don't have. So finally, kind of other odds and ends. Labs are going to be assigned like more or less weekly, except I'm not going to assign one at the end of this week. I'll assign one next week, just because this is kind of the introduction, and also UC Blackboard hasn't been set up yet. I definitely don't want to kind of put that stuff on you until I have like Blackboard to manage all the submissions and everything, because otherwise it just becomes extremely difficult to manage. So, I do plan to I do plan to get all of the labs together before the end of class, so I'll try and publish them as I get them done. I won't try and hold any back from you. So if I don't have some labs posted, that doesn't mean that I have a bunch of labs sitting on my computer that I can email you or something. That means I actually don't have them. And then homework submissions will occur through UC Blackboard unless specified otherwise. If and I know I had two students in a previous class who did fall into this situation because they were taking the class for cross credit through another university. If you do have a situation where you can't use Blackboard for some reason, let me know. Just shoot me an email, and then we'll figure out some way for you to submit stuff that way. And then assignments instructions will be posted publicly. So I mentioned earlier, we're going to have I'll just host like a web page for the course on Dr. Franco's server, and that'll be available publicly. So all the assignments that I post in Blackboard will generally just have a URL that's linking you to that. And then finally, I'm planning to host the website, and also I'm going to record the lecture videos and host them there too. So that was something that if any of you have taken Franco's courses, I know that he tends to do that. So I was going to try and also do that as well so that he could use it to help build up the material he's got for the cyber operations major. So that's the end of the lecture notes I have for today. Does anyone have any kind of questions or comments at the moment? Otherwise, I'd be happy to jump into say using VirtualBox for stuff. So I'll give like kind of a quick, because we've only got about say 10 minutes or so. I'll give kind of a quick demo of using VirtualBox a bit. So you can I usually just run it from the command line. You can also run VirtualBox over here. So if I do from here, same's true if you've got Windows. You're going to have I don't even know if they call it the start menu anymore, but you're going to have the little Windows icon that you can, if you've installed VirtualBox, then that works. Make sure that your laptop supports like secure virtual machine or something like that, has a processor that can handle virtualization. Most all laptops that are available today have it. If VirtualBox gives you kind of a warning that says your laptop does not support virtual machines, that may very well be that you have to change a setting in the BIOS that, for reasons that escape me, is usually set to off on every system that I've ever put together. So I've got a number of systems that I have in a cluster at home that I've been using, and every single motherboard that I bought has the virtual machines turned off. This laptop had the virtual machine option turned off in the BIOS. If you're getting the warnings from VirtualBox that say that it's disabled, and you can't find it in BIOS, feel free to reach out, and maybe I'll have some time either after class, or I may have some time during the office hours to try and work with you to get it through, to get it fixed. So I'll try and be really helpful in that regard, just because that's a necessary thing, and it's an extremely confusing aspect of PC hardware for some reason. I will say that most of the Macs, so if you use PowerBook, those all support it, and it's on by default on a PowerBook usually. I don't know about I think someone's got a Surface back there. I know the processor supports it in the Surface, but I don't know if the Surface. Okay, sweet. So there you go. So if you have Surface, it's probably working for you too. But this is basically how it's set up. There's two primary ways that you're able to create a new virtual machine on your VirtualBox system. Generally, if I provide, say, what's called an OVA file or an appliance file, it allows you to import it this way. So for instance, I can do this, and then let's see. Yeah, so for instance, this one, I've got a Windows XP image that I have exported as an OVA file that allows me to say give it to anyone, and then all they would have to do is do a single click import using this thing. So I can import it with this. The other approach, if you only have a ISO file, so you can see I have the Windows 10 that you get through DreamSpark. So you can install that as well, and I strongly recommend you do. You can install that on your on VirtualBox, and I can't remember if I've installed it in here or not. And then I also have Ubuntu 16.04.01. So if I wanted to, I could also click on this new, which doesn't import anything, but it actually allows me to create a new virtual machine. And if I pick the operating system I would like to install it, so this isn't choosing an operating system from a library or anything. This is me telling VirtualBox that I'm going to create an empty computer, but I want it to be a computer that has a hardware configuration that supports the version of, say, Windows or the version of Linux that I'm going to put in here. So I can pick like Windows 10, and then I can say like Win10 test, and then I can go over, I pick the amount of memory. This is going to vary for all of you depending on, say, what total RAM you have available on your system. I generally recommend to try and go with, say, dedicate no more than like a quarter of the RAM on your system to any single virtual machine, but also don't give yourself any less than 512 meg, so any less than half of a gigabyte. The reason I say don't go too high is because there probably will be situations later on in class where you will want to have two virtual machines running at the same time. So if you have two virtual machines that each are taking 8 gigs of RAM and you have 16 gigs of RAM on your system, you're going to start running into resource contention issues if you've given them both 8 gigs of RAM. The nice thing about virtual machines you don't get from setting up your own hardware lab is that you can shut down your VM and then you can just change the sliders to change the amount of memory that's available, that type of thing. So I'm going to leave this at like 2 gigs. I'm going to create a virtual hard disk. I always pick this one. I don't know what the other ones are, but you're free to do research if you want. Dynamically allocated is generally the better option, and it explains why up here. And so then I'm going to set it up. 32 gigs sounds fine. I think I have 500 gigs on this system or something. So then it creates an empty virtual machine. This is basically the same. I'm now at the same state had I gone out to Micro Center and bought a bunch of hardware for a system, except I've emulated it all in software right here. But one thing I don't have is I don't have Windows installed on this system. So I have to treat it just like a brand new computer, where I go in here and I insert Windows into the CD drive. So for instance, I'd go here, I clicked on the settings button up here, I go to storage, and because they know that you generally want to have a virtual CD drive on here, they always automatically add one for you. So you just look for it in this list. And then what I'm going to do is I'm going to pick a file. So, this one. And then I'm going to pick this Windows 10 educational DVD. And then I'm going to say OK. And now I saved it. And then I'm going to go back here and I'm just going to quickly go through these things. It gives you all sorts of flexibility to define what hardware that you're mimicking. So you can change the number of processors if you want. You can actually limit the amount of time that each processor will use. So this is equivalent to like frequency scaling or something like that. You can change how it does memory management, all that stuff. So you can do these things too. One of the nice things about VirtualBox, and I believe VMware also has this support, is you can expose video acceleration so that the video rendering that happens in the little window is actually nice and fast for you. You can also, if you're running it on another computer, say on a server or on a Amazon instance, if you set one up on an Amazon instance, you can actually provide a remote desktop as well. Or you can provide like video capture, so you can actually have it stream your entire session to disk and save a video for you. And that might be very useful, for instance, if you're trying to demonstrate how to do some specific action in Windows or something like that, or some specific malware analysis technique. to one of your fellow students. So it gives you all this stuff. I'll click OK, and then I'll start it up, and we'll see if it even boots off that CD drive. So, and now you can see it's booting off the Windows 10 CD drive. So that's kind of like a quick and dirty, this is how I get my virtual machine created from scratch, and then I give it a disk that I would like to install a brand new operating system off of. Now I'm not going to start installing Windows right now because it's going to take probably the rest of the night or something. But this will get you to the point where you'd probably want to be in order to start setting up your own VMs and messing with them.